Let's look at example 3 in our notes. It says, determine the equation of the function that defines each graph. Write each function in standard form. Okay, so this is very similar to the first two examples. We're basically just working backwards here. The first two examples, we took an equation and turned it into a graph. Now we're going to take a graph and turn it back into an equation. It's the same stuff, just working backwards. Okay. So the three key points that you want to use for these questions are your two x-intercepts, if you have two of them. Sometimes you don't. But we're going to find our x-intercepts, and you also need your vertex. Okay. So where are my x-intercepts? This is my x-axis right there. So that means my x-intercepts are at this point and this point. Okay. It's a little bit blurry, but 5 is over here. And then negative 5 is over here. This is negative 2. This is positive 2, positive 4, positive 6. That means 8's over there. Okay, so this point right there is going to be 0's here. 1, 2, 3. 3, 0. And that means this point down here is negative 1, 0. And that gives me a vertex of 1 and 8. Okay. So let's list this out. So x-intercepts are going to be, I'm going to write them in the form of equation. X equals 3 and x equals negative 1. Okay. And my vertex is at 1, 8. Okay, so there's my important points. How do I actually figure out my equation? Let's change colors here. Well, I know that my factor form equation looks like this. Y is equal to a times x minus r times x minus s, where r and s are my two x-intercepts. So what I can do is I can just take these two, the 3 and the negative 1, and put them right over here. Okay. So that's what I'm going to do. R is going to be equal to 3. S is going to be negative 1. So if R is 3, my first bracket is x minus 3. And if s is negative 1, that means my second bracket is s plus 1. Or sorry, x plus 1, not s plus 1. Cool. That's easy. We're almost done. We have to go find a, though. To find a, what you need to do is you have to substitute in your vertex. So we're going to sub in x equals 1 and y equals 8. Why do I use those two numbers? Well, that's because those are two numbers that work with my vertex. And what happens is I'm going to substitute in these two numbers, and then I'm going to go find what a is. Okay, so let's show you how this looks like. Y is equal to 8. That means 8 goes over there. My a just kind of sits around. Oh, why did it change color? My a just sits around. Nothing happens to it. Okay. The x minus 3 now becomes 1 minus 3, not y, 1 minus 3. And then the x plus 1 now becomes 1 plus 1. Okay, so what do we got? We got 8 is equal to a times 1 minus 3 is negative 2. 1 plus 1 is positive 2. If you multiply this out, you get 8 is equal to negative 4. Negative 2 times 2 is negative 4 times a. What is a? Well, we're going to divide both sides by negative 4. That's supposed to be red. This thing's not doing a good job changing color for me. Negative 4. Divide this by negative 4. That gives me a is equal to negative 2. Perfect. So let's put that back in my equation. My equation now becomes negative 2 times x minus r times x minus s. Oh, wait. No, it's not. I actually have to fill in r and s. So r is 3. S is negative 1, which means I need to flip that sign. Okay. So that's my equation. It's not in standard form, though. It does say write each equation in standard form. Standard form is y is equal to ax squared times plus bx plus c. So I'm not quite done yet. What I have to do is I actually have to multiply this out. Okay. So that means I have to use distributive property. I have to go like this. Multiply the two x's, then do x times 1, then do negative 3 times x, then do negative 3 times 1. So y is equal to negative 2. It's just going to sit there for now. X times x is x squared. X times 1 is 1x. Negative 3 times x is negative 3x. Negative 3 times 1 is negative 3. Okay. So this becomes, I can simplify the middle part a little bit. X squared minus 2x minus 3. Now I multiply that negative 2 in. So y is equal to negative 2x squared plus 4x. Watch the sign there. Negative 2 times negative 2 is positive 4. Negative 2 times negative 3 is positive 6. And there's my equation. Boom. All done. Okay. There's a second one down here, so let's do that second one. All right, let's go find our key points. Ooh, look at that. We have a nasty vertex right here. No, you know what? That vertex is making our life very difficult. Yeah, maybe let's not do this example. We're going to have to come up with a new one. This vertex sucks. Well, you know what? I'll do it now, but in future notes, we're not going to use this one because this vertex is terrible. All right, so here's my two intercepts. This is x is equal to 2. This is x equals negative 1. And my vertex is down here somewhere. This is a negative 2. So that looks like, let's call this like 0.5 and negative 1. What would that be? Well, actually, I don't actually need to use my vertex, do I? No, any point will work. So I don't actually need to use the vertex. Oh, yeah. So good lesson for you guys. If your vertex sucks, you can pick another point. Like any point that isn't the x-intercept, and it'll still work. Okay. So instead of using the vertex there, I'll use the y-intercept. Because that y-intercept is easy. That y-intercept is... Oh, no, I don't want to use my y-intercept, do I? No, this will work. My y-intercept is going to be 0, negative 1, so let's use that. Yeah. And you get to watch Mr. Lee kind of work this out and struggle a little bit. Okay. Just to show you that math teachers aren't just like superhumans, and they will still mess up from time to time. Okay. I could re-record this, but firstly, I'm lazy, and secondly, I kind of want to show you what it looks like when I didn't pre-do the questions, and I'm just like working it out as I go. Okay. All right, so let's work this out. Y is equal to a x minus r x minus s. Cool. Let's fill in r and s. So y is equal to a. I don't know what that is. We'll do that later. Let's do the left one for r. So r here is going to be negative 1. S here will be 2. Okay, so this is going to be x minus negative 1. That's the same as x plus 1. Okay. X minus s is going to be x minus 2. So there we go. Okay, now we're going to sub in our y-intercept. So we're going to sub in 0, negative 1. So that means y turns into a negative 1. A just sits there. X is now 0, so 0 plus 1. And then x minus 2 becomes 0 minus 2. So we've got negative 1 is equal to a times 0 plus 1 is 1. 0 minus 2 is negative 2. Okay, so this is negative 1 is equal to negative 2a. Okay. So if you divide both sides by negative 2 here, I get a is equal to positive 1/2 because I have double negative. Okay. So there we go. I'm almost done. Okay. Let's put it over here. Y is equal to 1/2. My a is 1/2. X plus 1. X minus 2. Okay. If I didn't say put it in standard form, I'm pretty sure it does say put it in standard form. Yeah, it does say that. So if I didn't, you could just leave it like this and you're done. But the question does say put it in standard form, so we're going to have to do that. I'm going to multiply here. If you guys have heard of FOIL, we're doing FOIL. If you have not heard of FOIL, that's okay. You don't need to know about it. We're doing distributive property. So x times x is x squared. X times minus 2 is negative 2x. The third one is plus x. The last one is minus 2. So y is 1/2. x squared minus x minus 2 times it all by 1/2. This is 1/2 x squared minus 1/2 x minus 1. And there we go. Alright. So that's how you turn a graph into an equation.